Page 117, let's do 44 is 15 over 16y minus 7 over 2y squared. Okay, so I need a common denominator, 16 and y squared. So that means I need to times this first term by a y. So I'll have 15y over 16y squared. What do I need to times my second term by? 8. Okay. Then I'll have minus, what, 7 times 8? Very good, 56. And then 16y squared on the bottom. Okay, now I have common denominators. So 16y squared is on bottom. What's on top? 15y minus 56. Will that simplify down at all? No. Okay, so there would be my final answer. All right, 15, there's no factors of 15 that will go into 56. Is there? Does 3 go into 26? No. Okay. So then that's as simple as it goes. Let's do 46. That's 3 over 6 a cubed b plus 9. No, that's a 5. 5 over 9 a b cubed. Okay, so let's figure out our common denominator here. What's the smallest number that both 6 and 9 will go into? 18. Okay, what do I times a 6 by to turn it into an 18? 3. Okay. What do I times a 9 by to turn it into an 18? 2. Okay, a cubed. That's the lowest a value I want to use. So I don't need to times this first set by anything. What about my second term? I need to turn that into an a cubed. Okay, so I need to times that by an a squared. How about the b? B cubed is the smallest term. That means I need to times over here by a b squared. So I'm going to times my first term by 3b squared. So up on top, I'll have 9b squared. And what's down on bottom? 3 times 6, 18, a cubed, b cubed, right? Okay, and I need to end up with that same denominator. So I'm timesing by 2a squared. We'll have 10a squared. And then 2 times 9, 18. And then a times a squared, a cubed, b cubed. Okay, now my denominators are the same. I'll have 18 a cubed, b cubed on the bottom. And what's on the top? 9b squared plus 10a squared. Can I combine anything? No, 9b squared and 10a squared won't combine. Okay. So that is our final answer. If I were to rewrite that in the correct alphabetical order, okay, just change it on the top. 10a squared plus 9b squared over 18a cubed b cubed. Let's try 48. I have a 3q over q squared minus 49 minus 3 over 2q minus 14. Okay, common denominator. So let's factor 3q, and then perfect squares, so q plus 7, q minus 7, minus 3, and if I factor out that 2, I have a q minus 7. So how do I get a common denominator? All right, I need to times this side by a q plus 7, right? And what do I need to times this first term by? 2. Okay, so on top, I'm going to end up with 6q. And on the bottom, I'm going to end up with 2 times q plus 7, q minus 7. Okay, and then over here, 3 times q plus 7 on top, and 2 times q plus 7, q minus 7. Okay, now my denominators are the same. So I'll end up with, sorry, I need to write smaller, don't I? 2 times q plus 7, q minus 7 will be my denominator. And then what's on top? I have a 6q minus, okay, so there's that floating minus again. We need to distribute that through. So I'll have 6q minus 3q minus 7. Is that right? Okay, so where'd you make the mistake? If I distribute this 3q plus 21. Very good. Okay, so then if I distributed the negatives through, that would be negative 21. Okay, so then combine your like terms, those q's. What's our final answer going to be? 3q minus 21 over 2 times q plus 7, q minus 7. Okay, can we take that one more step? We can. So if I factor this 3 out up there, 3, q minus 7 over 2, q plus 7, q minus 7. My q minus 7s will cancel. I'm left with 3 over 2 times q plus 7. Here's our final answer. Okay, let's do a few more. 52 over 4 minus p squared. So I need to put those in the correct order. Plus p over p minus 2. Okay. So this is really negative p squared plus 4. And if I factor out the negative 1, p squared minus 4. Okay, that one's factorable. So if I have 2 over negative 1 times p plus 2, p minus 2. There we go. Plus p over p minus 2. What's missing to make a common denominator? Negative 1, p plus 2. Okay, so I need to times everything over here by a negative 1 times p plus 2. So I'll have 2 over negative 1 p plus 2, p minus 2, plus, and what do I have on bottom? Negative 1, p plus 2, p minus 2, so there's our common denominator. And then on top, negative 1, p plus 2, and that was all times what? By p. Okay, so we'll come back to that. There's also a p there. Okay, negative 1 times p plus 2, p minus 2. There's my denominator. What have I got on top? I have 2 plus p. Okay, so here we're going to have trouble, aren't we? What happened when we times up there by the negative? Plus a p minus a 1 times p plus 2. So let's distribute that negative 1 through. So I'll have a 2 plus a p minus a p minus 2. Is that right? So I could rewrite this to be a negative p minus 2. Then I had p plus a minus p minus a 2. So I have a 2 plus p minus 2. So 2 minus 2 is 0, and p minus p is 0. So I've got a big 0 on the top. Zero over, what's on bottom? Negative 1, p plus 2, p minus 2. So what do we know when we're dealing with zeros? Okay. Make it all 0. Right, so we went through a lot of work and it was a 0. That's okay. Okay, back in the chapter, so we've added and subtracted, multiplied and divided. Now we need to simplify compound fractions. We're just going to take this one more step. It's the same thing we've been doing, but it's in fraction format, so it always looks a little bit scarier. Let's go to example 7. Page 115 has 2 over 3m minus 3 over 2. Okay. Then that's all over 3 over 4m minus 1 over 3m squared. How should I approach this? I'm dividing a fraction. Okay, so there's a couple of different ways. The first thing I need to do is find the lowest common denominator for all of my fractions. So here's our denominators, a 3m, 2, a 4m, and a 3m squared. So the lowest common denominator, what's the lowest number all of those will go into? Is it 12? And then I need an m squared. That's my smallest term. So there's my common denominator, 12m squared. So the first thing we can do is go through and make all our denominators 12m squared. So what do I do to a 3m to turn it into a 12m squared? 4m. So multiply by 4m, this first term. So I'll have 8m over 12m squared. Okay, how about my second term? What do I need to do to a 2 to turn it into a 12m squared? Okay, times by 6m squared. So 3, 18m squared, 12m squared. Okay, so I'm good on the top, right? Okay, now down below, what do I do to a 4m to turn it into a 12m squared? Times by 3m, very good. Okay, so I'll have 9m on top over 12m squared. And then what do I do to a 3m squared to turn it into a 12m squared? Okay, times by 4. So I'll have 4 over 12m squared. Okay, now my denominators are all the same. So can I do anything? Yes. Okay, what can I do? So let's combine. So I will have on the top 8m minus 18m squared over 12m squared. And then down on the bottom, I'll have 9m minus 4 over 12m squared. Let's rewrite that. 8m minus 18m squared over 12m squared. There's the top of my fraction, right? Okay. All over, what's 9m minus 4? 9m minus 4 over 12m squared. Okay, so we're still dividing fractions. It's just written in a different format. So I flip the second term over and multiply. I have 8m minus 18m squared divided by 12m squared. Then I'm multiplying by 12m squared, 9m minus 4. Can you see anything we can cancel? Okay, let's get rid of those 12m squared. That was why we found a common denominator, so that those terms would cancel. So I have 8m minus 18m squared now over 9m minus 4. Is there a way that I can do it? Can I do anything? Okay, what can I do? If I take a 2m out from the top, 2m times 4 minus 9m. That's starting to look similar. 9m minus 4. What do I know about that? Okay, I can turn that into a 9m minus 4 if I make this a negative 2m. So then those terms would cancel. And that's what I'm left with, negative 2m. Let's do a couple of these from the homework. Let's start with number 66. So I have 8 over x cubed minus 1 over 27. So there's my first two denominators I need to keep track of. Over 2 minus x minus 1 over 3. So there's my next two denominators. What's the smallest number? 27. Okay. Will 3 go into 27? Yes. Okay. So then variables, what's my smallest variable? X cubed. Okay, so there's the common denominator we need to work with, 27x cubed. So what do I need to do to an x cubed to turn it into a 27x cubed? We multiply by 27. Grab your calculator. 8 times 27, 216 over 27x cubed. Okay. And then our second term, I need to times by x cubed to get 27x cubed on bottom. So I'll have x cubed on top, 27x cubed on bottom. Okay, down below, I need to turn an x into a 27x cubed. And multiply by 27x. So 27 times 2, I have 54x over 27x cubed. And 27x cubed, I don't need to change this one. So x, oops, sorry, I was looking at the wrong thing. What do I do to turn in 3 into a 27x cubed? Times it by 9x cubed. Okay, so then on top, I'm going to have 9x cubed. Then combine 216 minus x cubed all over 27x cubed. That's the top part of our fraction. And then on the bottom I have 54x minus 9x cubed all over 27x cubed. Then I'm dividing fractions, so I need to flip that second term over, use the reciprocal, and multiply. So let's rewrite it. So I have 216 minus x cubed over 27x cubed multiplied by 27x cubed and then 54x minus 9x cubed. You okay so far? Okay. So then my 27x cubes are going to cancel. I'm left with 216 minus x cubed on top over 54x minus 9x cubed on bottom. So I'm definitely going to need to do some simplifying. So if I rewrite this, x cubed, I'll pull out the negative 1, x cubed minus 216 is going to be on top. I want to pull out a 9x on bottom. Let's make that a negative 9x on bottom. So I'll have x squared minus 6. Is that what we want to do? Okay, let's try it. Okay, looking at the top, I know that those are perfect cubes. So what's the cubic root of 216? Anybody know? Very good, it's 6. So on the top, I'm going to have -1. So my A value is going to be an X, and my B value is going to be a 6. So let's rewrite it. It's A cubed minus B cubed, so we need to use the A minus B format. And A squared plus AB plus B squared. There's top. And then what's down on bottom? -9x. Can we do anything with that? X plus 6, x minus x squared. I keep thinking there has to be a way. This has to simplify down one more time, but why can't I see it? -9x cubed plus 54x. So if we pull out the 9x, we're left with x squared minus 6. So I can't see a way to factor that. That's a pretty ugly looking problem. Alright, well, we'll call it good then. So I have this double negative here, so it really will turn into a positive. Okay, very good. Alright, let's walk back through and see what we can see here. Did we make a mistake somewhere? Let's check out that 54x. Where did we get that from? (27x). There we go, right there. That needs to be a 27x squared. So that's 54x squared, 54x squared, 54x squared. Okay, so is that going to change this? So if I pulled out a 9x squared, and that turns into an x minus 6. There we go. That was the problem. So that is a 9x squared. No squared there. So then the x minus 6 will cancel there. The double negatives will cancel. So my final will be x squared plus 6x plus 36 over 9x squared. Okay. So that's as far as we're going to go in this section. Continue to review. Those last few problems are the same idea. We're going to go into the next chapter and cover a few concepts really briefly on radicals and rationals. So page 120. Simplifying radical expressions. Remember, we talked about this before. If I have the square root of a number squared, the square root and the square cancel each other out. And I'm just left with the number. So let's walk through that. Let's say I have the square root of 3 squared. So 3 squared is 9. So I can rewrite that as the square root of 9. And the square root of 9 is 3. Okay, so there's our shorthand, right? This cancels out this, and I'm left with a 3. So the same applies. Let's say I have the cubic root of 2 cubed. So do it the long way. Cubic root, 2 cubed is 8. So the cubic root of 8 is equal to 2. So our cubic root cancels out our cubed. So that's an easier way to look at it, is my square root will cancel out my squared, or my cubic root will cancel out my cubed. They've got a couple examples here. Down under example 2, I have the square root of 169x squared. So remember, 169 and x squared are two different parts to this. So I want to take the square root of 169, which equals 13, and then the square root and the squared are going to cancel themselves out on the x, and I'm left with 13x. There's a couple of other tricky ways to do this. What if I have the square root of a number that is not squareable into other whole numbers? Let's say I have the square root of 18. I can rewrite that as the square root of 9 times 2. Then I can take the square root of 9, which is 3, and leave that times the square root of 2. See how that works? So here's a couple more examples. What if I have the square root of 49p squared? Remember, those are different. So what's the square root of 49? 7. And then the square root and the squared cancel each other out, and I'm left with p. Okay, how about this one? I have the square root of x minus 3 squared. What happens when I have the square root and the squared? Okay, they just cancel each other out, so my answer is going to be x minus 3. So we can make these as complicated as we want. What if I have x squared minus 6x plus 9? So I would need to factor that out. So x times x squared, and then factors of 9 that will give me a 6 is 3 and 3. Negatives both. So this is just another way of writing that exactly, right? It's x minus 3 squared. So I could rewrite that then as the square root of x minus 3 squared. So then my square root sign and my squared cancel out. And I'm left with, again, x minus 3. About this one. As the square root of 4a squared plus 12a plus 9. And my square root sign covers it all. So we'll factor what's in there. So factors 2a and 2a and a 3 and a 3. Right? Then you do the same to get rid of the square root sign. So plus 2a plus 3, so this can be rewritten as the square root of 2a plus 3 squared. So then my squares and my square root cancel, and I'm left with 2a plus 3. What if I have the cubic root of 64? So I can do it in my head if I've memorized my square and cubic roots, or I can use my calculator. The way to use your calculator is you'll need to use your second function button. So if you turn it on, you'll see there's a button that says y to the x, and right above it, written in yellow in ours, in smaller letters, is x, then the square root sign, then a y. That's the button you want to use. So you're going to type in 64, second function, and hit that y to the x button, and then 3 equals 4. So the cubic root of 64 is 4, or 4 times 4, 16, times 4, 64. How about if they're negative? What if I have the negative cubic root of a negative, oops, sorry. That shouldn't be the negative. I have a negative 125 x cubed. I'm trying to take the cubic root of a negative 125. So cubic root of 125 is 5, and because that's a negative, and it's an odd, remember? When I have an odd, then my number can be a negative. And then the cubic root of x cubed, my cubic root and my cubed cancel out. Negative 5x. So it works the same for fractions, it's just written a little bit bigger. If I have the cubic root of v cubed over negative 8, so just like when we work with fractions before, do each line separately. So the cubic root of v cubed, remember our cubes are going to cancel out, so what am I left with on top? A v. And then the cubic root of 8 is 2, and since it's an odd number, it can be negative. Any questions on that? So this can go as high as we want. What if I have the 5th root of z plus 7 to the 5th power? This is my 5th power, and my to the 5th root will cancel each other out. And I'm left with z plus 7. The only thing you need to watch for is if they give me an even root. So let's say the 4th root, and my number inside is a negative. Can I have a negative number to an even powered root? No, right? So an odd, I can have a negative times a negative always equals a positive. So if my power is an even number, then this cannot be negative. That means it's not a real number. If that had been the third root, can I do that? I can. So the cubic root of a negative 216 is a negative 6, right? Negative 6 times negative 6 is a positive 36 times the negative 6 again will give me the negative 216. So that's where you need to watch out for, is when they ask you to solve a problem that's not a real number. So if they give you an odd power and a negative, it works. If it's an even power and a negative, it does not work.